Okay, we are live, and I want to welcome everybody to Standing for Truth. My name is Donny, and I am your host for today's program on the pre-flood/flood boundary. It is a privilege to have Michael J. Oard back with me as a speaker for this important and exciting topic. We will be answering the question, where is the pre-flood boundary? Now, our previous program with Mike Oard was on the post-flood boundary, and this was a comprehensive presentation. This topic of flood boundaries is becoming one of my favorites, and Mike has done a ton of fantastic work on the topic. And in that program, the previous program to this one, we answered many important questions on this subject of flood boundaries. And so if you haven't yet seen it, please do make sure to check it out, as this program is in many ways a follow-up, or at least related to some of the points of discussion in that one. Now, Mike, he's been a great blessing to this ministry. This is actually his 10th time here on the program, and all of his previous presentations are linked in the description box for people to check out. You will find presentations and discussions on the receding floodwaters, the Ice Age, answering challenges and refuting objections to the Genesis flood, the Green River Formation, the Grand Canyon, flood boundaries, of course, and more. Now, before I hand it over to Mike for his presentation, I am first going to hand it over to my co-host tonight, Sam. Always a pleasure to have you, brother. And I'm going to hand it over to you for a proper introduction into our guest today.
Thank you. Yeah, I'm blessed to be here. So Michael has a master's in science degree in atmospheric science from the University of Washington, and is now retired after working as a meteorologist within the U.S. National Weather Service for 30 years. He has researched and speaks on the compelling evidence for Noah's flood and the Ice Age that followed, and how the incredible woolly mammoth connects to a biblical history. Michael has published many papers in his field, and he is widely recognized journals for his written Ice Age caused by the Genesis flood, an Ice Age, or I'm sorry, I just butchered your entry. Sorry about that, brother. Let me try that again. So he has researched and speaks on the compelling evidence for the Noah's flood and the Ice Age that followed, and how the incredible woolly mammoth connects to biblical history. Michael has published many papers in his field in widely recognized journals, and has written in an Ice Age caused by the Genesis flood, ancient ice ages or gigantic submarine landslides, the Methuselah flood controversy, and the Genesis flood, the frozen record. He is also the author of A Frozen in Time, the Weather Book, and Life in the Great Ice Age. You can find his introduction and more at mike@creation.com/Michael J. Oard.
Sam, I appreciate that formal introduction, brother. For people again in the audience, do check the description box for the relevant links. I've got several of Michael Oard's books with me, including the Mammoth one behind me, for you to check out as well. So we're going to be having a comprehensive presentation, followed by, as usual, an audience Q&A and a discussion between Sam, myself, and Mike. So if you do have questions, I have Sam here to help me organize those. Please do tag either myself at Donny or Sam in the chat, who goes by Redefine Living. And so with that, Mike, thank you so much for being here. And we're just going to hand you the floor.
Okay. Well, as Donny and Sam said, this is about the flood boundary. Controversial boundaries, just like the post-flood boundary. And from the title, you can see my position. I believe that most, if not all, the Precambrian sedimentary rocks are early flood. So the pre-flood boundary would be below them, and would include some igneous rocks and metamorphic rocks, but I'm not taking it that far yet. Anyway,
actually, Mike, before you continue, at the bottom of the screen, you'll see that it's got that bit of a rectangular box. If you click hide on it, it would remove that, and so there might be, yeah.
Got it. Okay. All right. it's important to figure out where the boundaries of the flood are and what are post-flood and what are pre-flood, because from my readings of the geological literature for 50 years, we have hundreds of questions to delve into and answer. And we got a lot of good answers, but we still have a lot that need answering, mainly because there hasn't been anyone working on a lot of these. But if we could figure out where in the flood it is, it'd go a long ways to answering these questions and producing a sophisticated or comprehensive flood model. Okay. And that we have, like I said, besides developing a comprehensive flood model, we can understand the powerful flood mechanisms if we understand the lower boundary better. And we'll know how the Precambrian fits into biblical Earth history. I will show the geological column several times to let people not familiar with the terminology know where the Precambrian is and how you subdivide it. I know that in this presentation, there will be those that are totally skeptic to creation science. So like I did with the flood, post-flood boundary, I'm going to start off with a presentation on the evidence that the stratas and fossils are from the flood, the big picture of strata and the fossils. What this talk is an internal controversy within creation science. So, but I'm going to start off with, we have the big picture in the strata and the fossils. Then I'm going to do a quick summary of what I talked in the last talk on the late Cenozoic flood, post-flood boundary. Many of you probably saw it, but it's a good refresher I'll give. Then I'm going to quickly mention the classic Precambrian Cambrian boundary as what many creation scientists have assumed is a lower flood boundary. And then I'm going to briefly mention 5 discontinuity criterion that were developed by Snelling, Wise, and Austin to try to determine the lower flood boundary, which is a good way to go, I'd say. But I've seen these as equivocal, and I will mention some of that. Then I'm going to go into the reasons why the Precambrian sedimentary rocks are from the early flood. Okay, strata and fossils support the flood. Strata often cover huge areas, sometimes half of North America. I'll get into this. And when you see cliffs, or you'll see sedimentary layers, they're laid one on top of another with little, if any, erosion between the different layers, or even within sedimentary packages. And the hundreds of billions of fossils in these sedimentary rocks is exactly what we'd expect in a global flood. And of course, Grand Canyons are centerpiece for this. It's about 4,000 feet of horizontal sedimentary rock and some Precambrian tilted rock, tilted eastward about 15 degrees. There's about 12,000 feet worth of that. It's probably, I don't think you see it on this picture, but there's several things you can determine here. The lower, my cursor works. The lower strata there is called the Tapete Sandstone, and it lays on the Great Unconformity, which is an erosion surface cut on mostly Precambrian crystalline rocks, but Precambrian sedimentary and metamorphic rocks in spots. And the Tapete Sandstone, I'll show you pictures of it, and that you can trace this over half of North America. You can trace it 200 miles through the canyon. It's about 100 to 300 feet thick. Unique sandstone, coarse grain with actual pebbles of quartz in it. Sometimes they're up to a centimeter in diameter. Then you see all these other layers, one on top of another. And you can trace these layers through much of the Grand Canyon, and they don't change much. Sometimes they thicken or thin. But you'll notice that this sequence represents 250 million years, they say. And yet there's little, if any, erosion within it. I'll get into this. And then at the top, you see a flat surface. At the broad scale, it's called a planation surface. And I'll be mentioning these as evidence. Here's a Tapete sandstone in the bottom of the Grand Canyon. It's coarse grained. It has small cross beds, and you can see pebbles of quartz in it. Now, I've seen quartz pebbles larger than what you see there. Now, up in my area of Wyoming and Montana, it's called the Flathead sandstone. It lies on the crystalline granite of the upper crust. This is the Flathead sandstone near Cody, Wyoming. I've seen it many places. It's equivalent to the Tapete sandstone. It has a different name because different geologists worked in different states and didn't really know they were connected. So when you put it all together, this is the approximate location of the Tapete sandstone. It covers about half of North America, and it continues through the Canadian Rockies up into northeast Canada, I might add. It doesn't cover the Canadian Shield because it's been eroded from there, if it was there to begin with. So at this point, it covers half of North America. What uniformitarian present process will count for a layer of sand 100 to 300 feet thick in general, with very few shale interbeds, coarse grain, covering half of North America? And this is a big problem. This is probably the best example, but a lot of other sedimentary rocks can be traced long distances. And this is exactly what you expect in a global flood, where it spreads sediment over huge areas and laying down layers one on top of another in quick succession with little or no erosion between them, which is the next point I'm going to make. This is 250 million years of deposition in various environments, to say shallow marine, terrestrial, etc. Well, if this is 250 million years and erosion on a million-year timescale is rapid, where is all the evidence of canyons and valleys in those walls of the Grand Canyon? Especially when they tell you that the western and central Grand Canyon that you see in the foreground was actually carved in only 6 million years. So you should see just all kinds of canyons in there. Actually, it should all be eroded off by now if it was millions of years old. Now here's erosion today. You can erode all continents down to sea level at the present rate in only 10 million years. That's at the present rate. But we can't extrapolate that rate back because man causes some of this erosion they measure from sediments going into the ocean. That messes things up. And as the mountains decrease, the erosion rate's greatest in the higher the mountains. And as it decreases, the erosion rate decreases too. It does not include coastal erosion, which will increase the amount of erosion. And some coasts are eroding pretty fast. Like the Arctic coast is eroding sometimes up to 7 meters a year. But you can put a max on it. Several uniformitarian scientists have dealt with these issues, and they put, say, numbers like 22 million years. But I'm going to use a conservative max of 50 million years. So if all the continents can be eroded to sea level in 10 to 50 million years, we should see plenty of erosion in 250 million years of strata in Grand Canyon. And here's a little sequence. And say this is just a sequence for, let's say, 500,000 years. Because if it's more than that, you totally erode the whole thing out. So here's 4 layers, 200 miles wide, laying on crystalline rocks. That orange pattern there. Give it about 100,000 100,000 years, and you're going to erode it. You're going to erode valleys like this. And then say it drops below sea level again, and more sediment is deposited, and it fill up the valleys and thin on the ridges like this. And then it can happen again and again to where you should see all kinds of valleys and canyons in there if it's just a 500,000 year sequence. But you don't see that. You see layers sometimes changing little thickness over 200 miles in Grand Canyon, and going way out and beyond, you can trace these layers well beyond the Grand Canyon. Sometimes they thicken and thin, as it's shown here. This is powerful evidence for one layer being laid on top of another in quick succession, not slow processes over millions of years. In this case, 250 million years. In this case, was especially emphasized in a book published by 3 secular geologists on the Teton Mountains. You're seeing the Southern Teton Mountains right here, which are sedimentary rocks in the Southern Tetons. It's the Central Tetons, which are the granitic rocks that pushed up along the Teton Fault, 30,000 feet of motion up compared to the granite in Jackson Hole to the east. But along the edges, the sedimentary rocks were not eroded off. And these represent the bottom 2/3 of Grand Canyon, even though it's about 600 miles to the north of Grand Canyon. They're very similar. There's one extra formation in there, but regardless, they're very similar sedimentary rocks. And you can see that's one layer laid on top of another. And these geologists said the regularity and parallelism of the layers in well-exposed sections suggests that all these rocks were deposited in a single uninterrupted sequence. That's what your eyes should say, your observations, because there's little or no erosion in there. But they don't do that. They say, however, the fossils and regional distribution, which is the fossils will be their theory, where they stretch out everything out into millions of years, of the fossils and regional distribution of the rock units show that this is not really the case. The incomplete nature of the stratigraphic record becomes apparent when the span of time represented by each of the various formations are plotted on the numerical time scale. Well, that sequence represents about 180 million years, and you have formations with gaps of 80 million years in places, but little or no erosion. It makes no sense. They should believe their eyes that it's an uninterrupted sequence, which is evidence for the flood. And of course, you have billions of dead things, actually trillions of dead things buried on rock layers laid down by water all over the earth. Powerful evidence. They're a lot of times well preserved, a lot of unique fossils with evidence of rapid burial. And sometimes in big graveyards, like in Montana where I live, there's a graveyard of duck-billed dinosaurs of the same species, 10,000 of them in one thin layer. And this is a graveyard of ammonites from Venezuela. And when you look at mollusks, clams, brachiopods, oysters, they're often closed-shelled. And shells, when a clam dies, the shell opens up pretty quick, days to weeks, because the attachments are organic matter and they rot quickly. And the fact that so many of these globally are found as closed shells indicates rapid burial globally. So these are powerful evidence for the big picture of the flood. And this is presented mainly for those that are totally skeptical of this, that would be looking at this program. So let's get back to a quick summary of the late Cenozoic flood, post-flood boundary. And here's the geological column. And the Cenozoic includes the tertiary and the quaternary, which is generally the Ice Age period, but not necessarily. There are some places thousands of meters of quaternary sedimentary rocks in some basins. So it's just another pigeonhole, the geological column. Parts of it are from the Ice Age for sure, but a lot of it isn't. And then here's the breakdown of it from various systems, Neogene and Paleogene. And here's a system right here in epochs. And here's a time scale. Right here is 65 million years, supposedly, at the Cretaceous Paleogene environment. Now, some creation geologists think that's where the flood, post-flood boundary. So all this Cenozoic in here is post-flood. But if you look at the Cenozoic closely, you find out that there are many huge events that occurred and many features that indicate that it could be post-flood. I will mention some of those. While I'm at it, the lower boundary is the Cambrian, Precambrian boundary right here, about 200, they claim 542 million years. The Precambrian is actually about 80 to 90% of the history of the Earth, from 4.6 billion years to 542 million. And they divide that up into three big eras: the Proterozoic, 2,500 million to 542 million, the Archean, 3,800 million to 2,500 million. And then below that, you have the Hadean, which there's hardly any rocks in that. It's supposedly when the Earth was molten, but no one hardly talks much about that period because there's not much evidence for it. But I'll be talking more about the Archean and the Proterozoic as we go. Anyway, various categories of Earth science indicate that the flood post-flood boundary is in the upper Cenozoic. And I must define the upper Cenozoic. I can't go by the precise uniformitarian datings because they move things around a lot. So I don't believe that the flood post-flood boundary is at the Pliocene-Pleistocene boundary. It could be down in the Miocene or the Pliocene. These are just slots, or even up into the Quaternary, or which is similar to the Pleistocene. Anyway, when you look at sedimentary rock evidence, there's a huge volume of sedimentary rocks in the Cenozoic. The South Caspian Basin, for instance, is 450 kilometers in diameter. It's approximately circular, and it has 26 to 28,000 meters of sediment. Let's say 26 to 28 kilometers of sediment. Most of it is Cenozoic. Maybe 20 kilometers is Cenozoic. And the top 3 kilometers is Pleistocene. And that's a lot for the Ice Age period. And I don't think that's for the Ice Age. I think that is from the flood. And it doesn't matter whether they label it Pleistocene or Pliocene or whatever. It's just a huge thickness. And you got to erode that thickness that's from somewhere and transport it to the South Caspian Basin, which I believe is a huge impact crater. Anyway, that's just several of them. I'm only going to mention a few of these. Then you got organic evidence. Coal. There's a lot of coal in the Cenozoic, even in the late Cenozoic, in places like Hungary, in Montana, southeast Montana, where I live. You have the Powder River Basin, which is Eocene coal. You have seams that are almost 200 feet thick of almost pure coal. And so if the boundary, post-flood boundary is below that, you're going to have to say coal formed in the post-flood period. How did that happen? You got to you got to gather a lot of plants. They got to grow, move them to a huge area. These seams a lot of times are 100 kilometers long and 40 kilometers wide, 200 feet thick of almost pure coal. And so you got to compress a lot of matter. And to form coal, you got to put overburden on it. And like for anthracite coal, at the average geothermal gradient, you need about 6 kilometers of sediment on it. For bituminous coal, somewhere around 2,000 to 4,000 kilometers, depending on the rank of the bituminous coal. They subdivide this. And then if the coal's at the surface, all that strata is gone. It's been eroded off, and it's not deposited nearby in a big floodplain. It's totally wiped off the continent. To me, coal is one of the strongest arguments that the post-flood boundary is in the upper Cenozoic or the late Cenozoic, which is the same thing. Tectonics. Practically all the tectonics you see in the mountains occurred in the mid to late Cenozoic. Sometimes a differential vertical tectonics of 40,000 feet or more, all in the mid to late Cenozoic. How is that going to happen after the flood? Lots of geomorphological evidence. John Reed, Peter Klebberg, and myself have been doing a big research project on flood sediments. And using the ocean sediments, which are mainly along the continental margin. In fact, I think I might have had a talk on this topic. But we've done a lot more work since that talk, I might add. We estimated that during the recessional stage of the flood, you eroded an average amount of 1,900 meters off the continents. And I've done a lot of these measurements, and I picked up a lot of secular measurements, and this is in the ballpark. The surface of the continents has been greatly scoured, which is why you don't find hardly any non-consolidated sediments on the surface. You go down below a soil and you get to the hard rocks pretty quick in a lot of areas. It's been scoured. So, and this is practically all in the Cenozoic. So how would you have that much erosion in the Cenozoic on all the continents? This is an average for the whole continents. And then you plane surfaces, like at the top of the Grand Canyon, I showed you that flat surface. In fact, I think I'm going to show you that again. Yeah, right at the top there, that flat surface, that represents erosion of anywhere from 8,000 to 12,000 feet of strata that used to be on there, eroding it down to a flat planation surface. This all happened during the Cenozoic. So how could you get that much erosion? How do we know there was that much erosion? Well, you go to the north, you find the Grand Staircase, which tilts down to the north about 3 to 5 degrees. And you see a number of formations. And so those formations used to be up over Grand Canyon. They might have thinned as they went up over Grand Canyon, because the Grand Canyon was generally an east-west arch. So there could have been thinner sediments. If there weren't, it was about 12,000 feet. Regardless, 8 to 12,000 feet of strata erode from the whole Grand Canyon area, leaving a flat planation surface, all in the Cenozoic. How can that be post-flood? Anyway, I have some climate and miscellaneous evidence. We have a lot of warm climate fossils at mid and high latitudes in continental interiors. That just cannot be after the flood, especially for that second and third reason, because you would have volcanic and impact winter that caused the ice age, for one thing. What's volcanic winter? Well, when you send up all kinds of particles from volcanism, the SO2 turns to sulfuric acid, which reflects a lot of sunlight back to space. So the volcanism from the flood would cause cooling of the continents, especially in the summer. And this would continue because a lot of volcanism occurred during the ice age, reinforcing it. So you'd have volcanic winter. You wouldn't have any time to collect warm climate fossils like in most of the Cenozoic. Shows warm climate fossils, even in the Pliocene. And then impact winter. The Chicxulub impact was at what they believe was the KPG boundary, and it sent up enough particles, they believe, and I've written about this, that you can cool off the average global temperature over 20 degrees centigrade and last 3 to 15 years. And this would act after the flood. So you're not going to have any chance to form any warm climate fossils after the flood. Anyway, I went through these quickly. You can, I went into them in a lot more depth in the talk on the flood post-flood boundary. But in a quick summary, we have, between Tim Clary and myself, we have 35 criterion that point to the flood post-flood boundaries in the late Cenozoic. Now, there's certain paleontologists that think that the fossils say otherwise, and I'm working on that. Which is a third point there, and it's not right in my directly in my field, but I'm able to get around and find some stuff. But it's pretty complicated, and I think what we need is a lot more detail in that argument. And I assume that the boundaries in the late Cenozoic, I mean, assuming the geological column for sake of discussion. Now, we could take away that. And that's why I'm not exact on where the boundary is. And I believe that we have to examine every place on its own merits. And we can use the 35 criterion to determine it. Now, some places are very hard to figure. Like the mammal fossils on the high plains is one area. Certain features of the Arctic and Northeast Canada is tough. The Australian marsupials are tough. I looked at that. I published this evidence in the journal Creation in the last couple of years. It's looking like those marsupials. By the way, in the early Cenozoic, you have marsupials on all the continents. That is, to me, clearly flood. But in the upper Cenozoic, you have a lot of marsupials in Australia. Yes, a lot. You have a bunch in South America, I might add, too. Looking at them, they sure seem to be post-flood. And they date them as clear down into the late Oligocene. So when I looked at that situation, I found out first they dated them as Pleistocene, which makes sense because that would be their Ice Age period, and that could easily be post-flood in our biblical Earth history. But then they looked at them closely and they found primitive features, what they claim are primitive features. And then they didn't have any, at that time, radiometric dates, so they used the stage of evolution to redate these things from Pleistocene down, some Pliocene, some Miocene, eventually getting to the late Oligocene for some of them. And I think this is just a house of cards. And the evidence is that the marsupials in Australia are post-flood, but have been misdated, stretched out. Anyway, I think we're going to now move on to the main topic. That was just introductory material. The third point. For a long time, many creation scientists have assumed that the lower flood boundary is at the Precambrian Cambrian boundary, because in the Precambrian you have hardly any macrofossils, metazoans. Well, in the above the Precambrian, what's called the Phanerozoic, starting with the Cambrian explosion, you have a huge number of these animals. So it was reasonable to put the boundary there. But when you look at it in more detail, I think there are other issues to consider, which I will get into. So here's the geological column again, and the classical boundaries at the Precambrian Cambrian. And so we're going to get into this a little more, but that's where the classic boundary is. there are three main positions. Actually, I forgot one here. Actually, there's five. One is the Precambrian is pre-flood. In other words, that's a classical case that has been believed for many years by many creation scientists. Precambrian, Cambrian. And then there's a group that believes that the top of the Precambrian, called the Neoproterozoic, is part of the flood. So anything below the Neoproterozoic is from creation week. Nothing happened between the creation and the flood, which probably generally true. Now, the Proterozoic is divided up into three sub eras. You have the Paleoproterozoic, which is 2.5 billion years to around 1.8 billion. Then the Mesoproterozoic, which is about 1.8 billion to 1 billion. And the Neoproterozoic, which is 1 billion to the base of the Cambrian at 542 million years. I'm using their time scale for just discussion purposes only. I want to let the listener know that. So there's one group that says the Neoproterozoic is from the flood. And that below is from creation week. And then there's a third position that believes that all the Precambrian is antediluvian, in other words, between the creation and the flood. There's not very many people that believe that, but I know of one. And the fourth position is most, if not all, Precambrian strata is from the flood, and that's my position. And I'll give you the reasons why as we go. But there's a fifth one that I totally forgot. Because of stromatolites, a creation scientist, Ken Colson, finds stromatolites in the Cambrian in southeast Utah and thinks they're biological. And a stromatolite, I forgot, I didn't include any pictures in this talk. That's another controversial area. He believes they're biological, but it takes a lot of time to form these stromatolites. So therefore, he believes those stromatolites in the lower Paleozoic are pre-flood, which puts the pre-flood boundary in the upper Paleozoic. I don't think there's too many creation scientists that buy into that, and that's probably why I forgot to put it here, but I should have, just to be inclusive. And then, like I said, the classical lower boundary is based on few multicellular organisms in the Precambrian and billions of them after the Precambrian, starting with the Cambrian explosion. So let's get into the fourth subject. 3 creation scientists have developed 5 discontinuity criteria. Now, Carl Frody and I examined these, and we found them rather equivocal. And I hope to share some of these reasons why. The first discontinuity is paleontological, which is the classic reason for believing the Precambrian Cambrian is the boundary, because they're of the multicellular organs. But we're finding more and more multicellular organisms in the upper Precambrian. So I don't know. That's a question. Then we have an erosional discontinuity, which says that the lowest unconformity with sedimentary rocks, or a nonconformity between sedimentary rocks and crystalline basement, would most likely be the discontinuity. And these are actually fairly good, but like I said, when we looked at them closely, they're equivocal. And you can see the references: Austin and Wise and Snelling. Austin and Wise was at the International Conference on Creationism, and Wise and Snelling published in Origins. And a time discontinuity, the lowest and most significant time gap, they believe. A sedimentary discontinuity at the base of the lowest finding upward sequence. A finding upward sequence could mean two things, a deepening water, or it can be caused by increases of, or I should say a decrease of the current. Then a tectonic discontinuity at the lowest tectonic level. So here's some of the issues that Carl Frody and I found. For the first discontinuity, being paleontological, they're finding more late Precambrian multicelled organisms. So you can't say that the Precambrian and the Cambrian totally divide multicelled organisms exactly anymore. But these would be late Precambrian, so you don't find them too far down there. Also, there's reasons why you shouldn't necessarily find a lot of Precambrian organisms. Is that the Precambrian shows a huge amount of catastrophism, and I will show you some of that coming up. And a lot of that would destroy multicelled organisms, either pulverism by turbulence and fast currents. Meteorite impacts would cause such turbulence that it would destroy practically any organisms. And so, and maybe heat might be part of it too. So there's reasons why the Precambrian would not necessarily have multicellular organisms, or at least too many of them. But the Precambrian has multiple microorganisms, lots of those. So how do they fit in? And then you have eukaryotic cells, which are more complex cells than prokaryotic, and they are dated as old as the late Archean, older than 2.5 billion years. So I find the paleontological discontinuity equivocal. Erosional discontinuity. Well, they use the Tipete sandstone and the Great Unconformity as their major unconformity to place their boundary. But there's another unconformity, some people call it the greatest unconformity, below the Precambrian sedimentary rocks. At the beginning of the talk, I mentioned we have Precambrian sedimentary rocks, mainly in the eastern Grand Canyon, tilting to the east about 13 to 15 degrees, about 12,000 feet of them. At the base of those, along the upper crust, you have a flat surface, a major unconformity there. And so that is well down in the Precambrian. So that is another major unconformity. And maybe it's even more significant than the great unconformity. So we find that the erosional discontinuity is equivocal because we have two major unconformities in the Grand Canyon. And of course, there's lots of erosion in the Precambrian. And it's governed by location, elevation, slope, available water, and its energy. So you'd have a lot of unconformities in the Precambrian, and you do. So we don't see this as being too significant of a criterion for the great unconformity and the Cambrian above it. A time. How do you know how much time was elapsed in all that? You don't. It's an interpretation. It's not observed. The most likely time discontinuity would be between Precambrian sedimentary rocks and the crystalline rocks below. So I think that's the most significant time discontinuity down in the Precambrian. And as far as a sedimentary continuity, finding upward sequence, you should find these to be common all through the flood and possibly in the pre-flood. And you find finding upward sequences in the Precambrian sedimentary rocks. As far as the tectonic discontinuity, I think that's quite variable. I think you have a lot of tectonics show up in the Precambrian, and a lot of erosion could erase them. So these are some reasons where Frody and I, we wrote about this in the Creation Research Society Quarterly. And you can read about it, I think 2007, 2008. Now we get to the reason why I believe the Precambrian sedimentary rocks are early flood. By the way, I just got done with COVID, so I'm not altogether sharp tonight, but I'm doing a lot better. So what are the reasons? This is the main part of the talk. Okay, let's get into that geological column. Remember, the Proterozoic is divided into three: the Paleoproterozoic at the bottom, Meso in the middle, Mesoproterozoic, and Neoproterozoic at the top. And the Archean, which is older than 2.5 billion years. Here's my evidence. When you look at the Precambrian, you find large-scale catastrophism congruent with the flood mechanisms, which are very violent. The fountains of the great deep and the windows of heaven being open. And they together form the rain. The windows of heaven being open don't necessarily mean the rain, because there's a period at the end of that. And then it says starting the rain 40 days and 40 nights. Precambrian impacts would devastate life on Earth in the Precambrian. This is especially why I've come to believe that the Precambrian sedimentary rocks are from the flood. And I will especially embellish on this. And you find a continuity of certain unique rocks from the Precambrian up into the Cambrian, as if there's no boundary there, the classical boundary. And these include black shale. Now, black shale, there's a lot of black shale in the Precambrian. Black shale is high organic shale. A lot of organic matter in the Precambrian. Where did that organic matter come from? Well, I believe it's probably from pulverized organisms from all the catastrophism. Also carbonates. You have a lot of Precambrian carbonates, and they continue up into the Paleozoic with no boundary there. Quartz arenite sandstone. Quartz aranite is a very special sandstone which the grains are well rounded and practically all quartz. It's very unique. It doesn't appear to be forming today, even though it's claimed that possibly in the tropics, like Central Africa and the Rain Belt, and in the tropics of South America is forming. But a lot of times it's only forming high quartz sand, but not rounding the grains. So when you do both, it's exceedingly rare for it to be occurring today, if it even occurs today at all. But you have a lot of it. A lot of the sandstones are quartz aranite. And you find them in the Precambrian. A lot of them in the Precambrian, they go right up into the Paleozoic. And then after the Paleozoic, there aren't too many above that. And I think that these unique sandstones tell us a lot more about the Precambrian and the Paleozoic. But that's a sub topic for another session. And phosphorites. Phosphorite is sediment with a high potassium oxide or phosphate in it. I think that over 19%. And we have a lot of phosphorites on there. I'm going to show you a plot with time. I wish I had plots with time for black shale carbonates and quartz aranites. They're probably out there. I just haven't found them. But regardless, you find a lot of them in the Precambrian, and they go right up through the Cambrian, up in the upper Paleozoic, with no real discontinuity at the Precambrian Cambrian boundary. And then in my area, western Montana, stretching into northern and central Idaho and extreme northeast Washington and adjacent Canada, we have what's called belt supergroup strata, which I'm studying. It's dated Mesoproterozoic. That means about 1.5 billion to something like 1.2 billion years. Mesoproterozoic. Since it outcrops in here, we've seen the contact between the Cambrian flathead sandstone and the belt. And there's a billion years missing at the contact, and yet where I've looked, it's the contacts are conformable. Doesn't show a gap there. And it looks like the sedimentation was from the Mesoproterozoic belt clear up into the Cambrian, continuous. Now I'm going to embellish on all these. Okay, the first one, Great Precambrian catastrophism. We have huge rifts. These rifts are on the crystalline upper crust. Just blow your mind. I'm going to show you a picture of the major one. A lot of deep basins, which I believe are probably impact craters. We had tremendous tectonics during the Precambrian, enormous erosion and deposition, but the deposition was mainly in basins and rifts, which makes sense because you have fast currents, a lot of turbulence, but the only place you can deposit sediments at this stage would early in the flood would be in basins where the currents would be slower and in rifts, big cracks, faulted cracks. Also, during the Precambrian, you have to erode the great unconformity. And this great unconformity probably stretches from the western United States to the central U.S. below the sediments. And you have great unconformities on other continents also. It's a huge erosion surface on the upper crustal granites and other types of rocks. So this is huge catastrophism. Okay, here's a rift. This is called the Mid-Continental Rift. It goes from northeast Kansas with a gap there through Iowa, Minnesota, Lake Superior, and down into Michigan. That rift is a huge faulted down, and I wish there was a scale here, but it's about 50 miles wide. And look at the depths. By the way, this material has not been published anywhere. The secular geologists have not done this. This is practically all done by Dr. John Reed, creation geologist, as part of our team in the flood sediment project. But notice some of the depths. The blue area, mainly below Lake Superior, is below 80,000 feet, 30 kilometers deep, filled in with sedimentary rock. All this has been filled in with volcanic and sedimentary rock. But this is a huge crack or rift. And there's other rifts down here south of Michigan, down in southern Illinois, southern Indiana, Kentucky. Ours, I believe, the Real Foot Rift. EC is the East Continental Basin or Rift. AP stands for the Appalachian Basin. As you go east, it goes the Precambrian goes down, and you collect. And in the Appalachian Basin, you have 6-10 kilometers or more of sedimentary rocks. But the Appalachian Basin is very elongate, just west of the Appalachian Mountains. But this is a rift that occurred in the Precambrian. And John Reed and even Tim Clary believe that this is early flood rifting. This is, and like I said, these are filled up with 20, 30 kilometers of volcanic material, basalts, a lot of basalts, and sedimentary rocks in this rift. That's a huge amount of catastrophism. And then here's the trace of the mid-continental rift right here still. And we have these deep basins, and these are in meters, I believe. So this is the Williston Basin. Look how circular that is. It goes down over 12,000 meters. Here's the Michigan Basin, which I think is another impact crater, and the Illinois Basin, and these rifts down in here. This is all new stuff. You can't even find this in the secular. This is based on thousands of well data, maps of the Precambrian surface. In fact, that's what this is, the map of the Precambrian surface. And in basins, the surface goes way down and it's filled with sedimentary rocks. So that's a lot of catastrophism for the Precambrian. And this piece of evidence was especially why I believe that the Precambrian sedimentary rocks are from the flood, because we had huge Precambrian impacts. The Vredefort impact in South Africa, the crater diameter is estimated to be 250 kilometers, and the bolide that hit would be about 20 kilometers in diameter. And then in southern Ontario, you have the Sudbury impact crater. Actually, it's not much of a crater. It's more of a remnant of the impact melt. And it's 200 kilometers in diameter, around 17 kilometer bolide. And then in the Archean, remember the Archean is older than 2.5 billion years, they have found spherules in Western Australia and Eastern South Africa. And they're widespread. They're up to almost a meter thick of these things. And there's been a lot of research on this. At first, a lot of geologists didn't believe that they could be from impacts. So there was a lot of skepticism at first, but now there's hardly any skepticism. And they've settled down to that these represent anywhere probably around 11 impactors that are 10 to 100 kilometers in diameter. There's no craters associated with them, but it's just the spherules in these thick sedimentary rocks in Western Australia and Eastern South Africa. Now, we can't have such huge impacts in Creation Week. Remember, one position would say that these were from Creation Week. And how would you do that? How would you explain that and destroy all life on Earth? And it can't be before the flood either, because you're going to destroy all life before the flood. Now, the Vredefort and Sudbury impact are dated at about 2 billion years, about in the Paleo-Proterozoic. So they're pretty far down in the Precambrian, assuming the Precambrian timescale for relative purposes only. Now here's the Vredefort dome right here. And this is the original crater rim. And it's in a big basin right in here. And from space, you see the dome. In fact, in this area, they believe 9 kilometers of sediment have been eroded off. So you're seeing the lower part of the impact structure. And this is the center of it right in here. I wish there was a scale. These are vertical strata right in here. Go like this, or should. But this is just the inner part of the Vredefort dome. I'm still contemplating on what they mean by 9 kilometers of erosion to get to at this point. That is huge. So, and the same thing with Sudbury. They believe this represents 5 kilometers of erosion in southern Ontario. This is the Canadian Shield. So we do know there's been a lot of sedimentary rocks that have been eroded on the Canadian Shield because there's erosional remnants here and there. So I'm still contemplating what all this erosion means on these. These are shield areas with evidence that there was a lot of thick strata that was eroded sometime. Anyway, this is the patch of impact melt from the Sudbury impactor, which was 200 kilometers in diameter. And this is a cross section. So it's mainly the melt that you're seeing here, and it's only part of it. The rest has been eroded. So these are huge impacts. Now, the significant thing about these impacts is the destructive potential. Now, you could do a calculation from the Earth Impact Database program, and you can put in the parameters of these two impacts, and you'd find out that the wind would destroy most of the surface of the continents if the wind gusts over 50 meters a second. But that program has an error for large impacts, because when the fireball spreads out and the wind spreads out, it spreads out linearly, but the Earth is curved, and so it goes above. So as it turns out, instead of destroying all the continents, if the area was the same before the flood as we have now, you only destroy 15% of it directly. This is direct destruction by the fireball and strong winds. That's still a pretty good amount, 15% of the continents. But there's another factor in all this, that when you spread all this material, debris, and spherules up into the atmosphere, they come down. And when they hit the atmosphere, frictional heating heats the atmosphere, the upper atmosphere, to 1,600 degrees centigrade. And that radiates up and down, infrared radiation. The downward radiation would start global wildfires. It would start global fires globally. And it would result in the Earth shrouded in total darkness. We'd have impact winter for sure. Acid rain, ozone shield could disappear. That's the destructive potential just with the Vredefort and Sudbury impactors, not to mention those Archean ones, which were actually believed to be larger impacts. So this is all in the Archean and Proterozoic. So I believe you can't have those impacts before the flood, because you're going to destroy practically all life on Earth before the flood. And they can't be during creation week. So the only solution I can see is that most, if not all, the Precambrian sedimentary rocks are from the early flood. So impacts, I think, are a major factor in placing the lower boundary much lower than people have been saying. And then here's one of those types of sediment that go right through the Cambrian from the Precambrian. That's right here. That's the classical boundary. And so you have phosphates that are way down, clearing the Archean, a little bit in the Archean, the Proterozoic, and then the late Precambrian, the Neoproterozoic, you have a lot of them, so forth. And you have them in the Phanerozoic too. This is where the sediments contain, I think, greater than 19% phosphate, P2O5. And then here's the belt rocks. It's called the belt supergroup or the belt Purcell supergroup. It's called the Purcell supergroup in Canada and the belt supergroup in North America. And that's the approximate location, but it actually extends underneath the sediments further to the east. You can see it's generally circular. I think it's a gigantic impact crater. And I'm not the only one. There's secular scientists who've said this, even though they changed their mind later. From the University of Montana in Missoula, David Alt and a guy named Sears wrote a short article believing it was an impact crater. And by the way, for the Williston Basin, the Michigan Basin, the Indiana Basin, there are secular scientists who do believe that they're impact craters, besides myself. Now, this supergroup is two or more groups of strata, and a group is two or more formations. There's about, I think, 50 formations they claim in the belt Purcell supergroup. The current depth of this strata goes down 20 kilometers in northwest Montana, in southern Canada, and in northern Idaho. It's a deep, and by the way, it almost looks like that it was deeper than that, and it's been pushed up because the top of this has been well eroded into mountains. This is a very mountainous area, and in fact, there's a lot of practically all these rocks are metamorphic, lightly metamorphic into quartzite and a metamorphic shale called argillite. And there are places with 10 kilometers of quartzite, which is a metamorphic sandstone. And as this came up late in the flood, the top got eroded, and the big, thick quartzite layers got broken up and rounded, and those rounded rocks were spread clear into central Saskatchewan and southwest Manitoba, clear into North Dakota, clear to the Pacific Ocean, well into Wyoming, 800 miles from their source. Late in the flood, spread these rounded quartzite rocks, which I have a huge literature on this, by the way. It's powerful evidence for the runoff of the floodwaters. And this is in the Cenozoic, I might add. But the belt is greatly eroded at the top, and it's still 20 kilometers thick right now. It probably was 30 kilometers thick, and it's been pushed up that much. Now, in places on this belt, remember it's dated 1.5 to about 1.2 billion years. The Cambrian flathead sandstone lies on it in places. And here's one of them at the top of the Bridger Mountains, northeast of Bozeman, Montana, where I live. You have I'm surrounded by mountains, by the way. And this range goes up to almost 10,000 feet. And what you're seeing here is tilted strata. This strata is tilted down to the east about 60-degree angle. Some of it's about 80-degree angle. But it's a series of tilted, huge tilt, thousands of meters of tilted rock. But here's my friend Peter Kleberg, and where he is, that's the boundary between the Precambrian belt and the Cambrian flathead sandstone. It's conformable. You can't really see you can't see a real distinct boundary. It just kind of they blend into each other. To me, this is and you have a gap of almost 1 billion years between the Cambrian and the Precambrian at this location. And there is no sign of erosion there for that 1 billion years. To me, the big picture is that as the Precambrian belt was being deposited, just continued up into the Cambrian, and with no real no difference. No, it didn't. You don't have a gap there. And this strata above here, there's the Ordovician is missing. In the next layer, the Silurian is missing. And then finally get into the Devonian at the top of the ridge, where you find a lot of Devonian fossils. So this is another reason why I believe that the belt is from the early flood, and it's Mesoproterozoic, up to 1.5 billion years old, supposedly. So these are reasons why I believe the Precambrian sedimentary rocks are from the flood. And I think, and that ends my presentation. So now I'm open for questions and answers.
Mike, as always, very comprehensive and worth another dozen watches, probably, just like your flood boundary presentation from a month or two ago, which I highly recommend people in the audience please check out. We have a ton of excellent questions, some technical ones, some important ones. But before we get to those questions, Mike, there's a couple things I'd like to point out from your presentation. I made a lot of notes. And closer to the beginning, you went over many of the lines of evidence that best support a higher flood boundary.
Right.
And one of those lines of evidence that fascinate me and continue to fascinate me that you present has to do with the coal in the Cenozoic, including the late Cenozoic. Now, I find that to be not only amazing evidence for the flood itself,
yes,
but also for a late flood boundary as compared to a lower flood boundary. And
exactly.
And you asked the question, if the post-flood boundary is below that, where we find these hundreds, 100 to 200 feet of coal at least, thick, then all of this coal would have had to form during the post-flood period.
Yes.
And so, how would that be possible? What have you heard in response to that from somebody who holds to, let's say, a KT flood boundary? How would they account for that?
They brush it off. I saw, I'm not going to mention names, but one guy just simply brushed it off, didn't really get into it. In fact, two guys brushed it off. What I have discovered is that these 35 criterion are being ignored, and they glom onto the fossils to make their point. The fossils are complicated, I'll admit, but how can you go against 35 criterion, one of the strongest being coal? So there's something wrong somewhere in the fossil arguments, and I haven't quite pinpointed it yet, even though I have some hypotheses, which I'm not going to share. They really haven't examined it yet, and I want them to do that. So if you're one of those people that believe in a low flood, post-flood boundary near the KPG boundary, please examine these 35 criterion. And I didn't make these up. These are I'd say pretty solid from the literature.
Right.
And I might add that I might have had a bias for a KPG boundary when I first got into creation geology. And the reason I did is because, well, some of the geologists at that time believed it. So I said, well, they must be right. But then as I learned more and more about geology, I found huge contradictions and so forth. And that's why I've developed these criteria. And they've been published. I have a whole book on my website on them. But we individually in the various areas in 6 articles in the Journal of Creation they've been published. I don't know if they're online or not, but that's where they've been published in detail and people can see. Right. Well, I just totally don't understand why certain creation scientists have not looked at these closely.
Well, before you started giving your very comprehensive presentations, I was personally kind of agnostic on the flood boundary. I wasn't sure. But after your presentations, I'm thoroughly convinced that the flood boundary is higher. And your last presentation, at least, has been available for a couple months. Lots of excellent feedback, positive feedback, but no responses to the, and this basically brings me to the first question here, which in a way you did answer. And so if you wanted to elaborate, you could. And so I haven't seen any real response to the 35 points for a higher flood, post-flood boundary. And you're saying that continues to be the case, Mike?
Yes. And I have some very recent correspondence on that. So, yes, I do. And I'm not going to mention any names or anything like that. But so, yes, it continues to be like that. And that is not scholarly. Not scholarly. I'm examining the fossil evidence. I've wrote 4 papers on the fossil data so far. 4 papers in the Journal of Creation, and I need more. So I'm trying to address their only argument they seem to have is the fossils, the mammal fossils mainly.
Well, what do you believe is should be paramount in determining flood boundaries? Data from paleontology, basically fossils, or data from geology?
Well, I think all of it should be examined, but the fact is that we have 35 criteria that are mainly from geology, and some of them are from fossils themselves. In fact, speaking of fossil mammals, and the reason this is used is because we know that the mammals that we have alive today and in the Ice Age spread off the air rat. So if you're using the mammal fossils to say that it's a low flood, post-flood boundary, you have 2 of the criteria I developed are with these mammal fossils. You have to say, number 1, hardly any mammals are buried and fossilized in the flood, which should be in the Mesozoic, and then tens of millions of them in the Cenozoic after the flood. That doesn't make any sense. And then when you look at the details of these mammal fossils from the secular literature mainly, they have numerous fossils suddenly popping up in the strata, say Eocene, and then suddenly they go extinct, say Pliocene, globally at the same time in biblical Earth history, if you use the geological column as a relative time scale. So you have hundreds of these origins of mammals and extinctions of mammals in the Cenozoic that have to be explained after the flood, and I'd say that can't be done.
Well, it almost seems like you'd have equal catastrophic events post-flood that you'd have with the flood itself.
Oh, exactly, especially when you have more Cenozoic strata than any other period in the geological column. So you have huge amount of strata, and some people say it's just localized. No, sometimes it's exceedingly extensive, like the Fort Union Formation in Montana, North Dakota, South Dakota, Wyoming, about 400,000 square kilometers before it was eroded. And the top's been well eroded. There's no doubt about that. So it's just, I lost my train of thought. Sorry about that.
No, that's good, Mike. So a question that I have then is, firstly, to set a little context. You did a presentation with us a while ago, probably about a year, on the Green River Formation.
Yes.
Which applies to the flood boundary issue because depending on your position of the boundary, you're going to say the Green River Formation's flood or post-flood.
Yes.
Now, my question is, creationists who hold to a lower flood boundary and therefore would argue for the Green River Formation being post-flood.
Yes, they would.
I've seen them support their position by claiming the formation itself comprises a complete ecosystem. What would be a good way to respond to this?
Well, I'm not sure. There are features that they brought up. Me and another creation geologist spent about 10 days out there looking at it. He had the opposite view as mine, and we got along, did it charitably, which should always be done, I believe. Mm-hmm. So he brought up things that I couldn't explain, but I brought up things that he couldn't. The big picture, that's kind of what I look at. The big picture of the Green River Formation is it covers 40,000 square kilometers. It averages at least a kilometer thick. Some places, I believe it's 6 kilometers thick at the southeast of the Uinta Mountains. And it has tropical fossils, crocodiles, palm trees. And just recently, they found a huge ant that they believe is from a hot environment in the Green River Formation. So if that's the case, the Green River Formation is in a continental area away from onshore flow, and it straddles the continental divide. How are you going to get tropical fossils there after the flood? Secondly, it has enough oil in the shale to supply all the energy needs of the United States for 100 years.
Wow.
Where's that going to come from after the flood?
Right.
And let's see, there's several others. I had about 8 of them originally, but I boiled them down to 4. Let's see. Oh, yeah, the erosion. You go up in the Green River Formation, you find out that a lot of its top has been eroded. In the fossil basin, you find out there's been 2,500 feet of erosion. But that's not all. You go south of the Uinta Basin to where the Green River Formation used to be on the San Rafael Swell. The San Rafael Swell is in the northwest Colorado Plateau, and it's about 75 miles north-south and about 40 miles east-west. And it bowed up, and the top of it got eroded, but it left the limbs along the edges of it still there. And so you can drive from a pass north of Price, Utah, down to Price, and the strata are dipping about 8 degrees to the north very consistently. And by trigonometry, you can find out how much erosion occurred over the top of the dome, the San Rafael Swell. And we calculated 17,000 feet was eroded, 17,000 feet. And the top formation is the Green River Formation, about 2,000 feet of it. So you'd have to say the Green River Formation had to be deposited 2,000 feet deep at that spot, bow up in the San Rafael Swell, 17,000 feet of erosion of the middle of that occurred, and the erosional material is not found in a floodplain nearby, but is totally gone off the continent. So it's, to me, the big picture is that the Green River Formation is from the flood. Now, how to account for all those details in there, whether it has a total ecosystem, I hadn't heard that, but I've heard other evidence in support. I don't know. It's one of these things we need to first pinpoint whether it's flood or post-flood, and the big picture says flood. Then we go into these details and then explain it within the flood paradigm. But it's a tough area. There's a number of tough areas. Some places are easy to determine the boundary. Other places are tough because a lot of unique things happen in the flood.
Right.
So, but if we could determine its flood, then we can analyze it from that viewpoint. And that makes it that much easier to explain the details if you know where it fits. That's why I'm so keen on figuring out the upper and the lower boundaries. And those boundaries essentially is saying practically all the sedimentary rocks are from the flood. That's essentially what I'm finding, and that makes sense
Right.
to me. But I will admit that it brings up a lot of questions, and so we have a lot of explaining to do. But I think it can be done, especially if we know where it fits in biblical Earth history, whether it's pre-flood or flood or post-flood. That will help a lot in figuring out the details.
Well, you're doing some fantastic work on this subject. And I think, as you're putting it, there may be some observations or data points that require some additional research.
Oh, yeah, lots
But
of them.
when it comes to the bigger picture, I find that there's precluding data that you're pointing to, like the coal, like these massive features that kind of baffle the mind as to how they could be formed post-flood, that tell us, okay, the boundary is here, a higher boundary. Now let's explain some of the details, like the ecosystem questions, basically.
Yes. And I think we could get some really interesting things that happened during the flood when we look at the details.
Mike, I'm going to ask one more question here, at least on this flood boundary issue. And then Sam, I know you have some questions too, brother. So I could talk to Mike all day on the flood boundary, such an interesting topic. But one question I have, and I've seen this brought up frequently, including in some recent articles. And so for the audience, I'll put it up on screen. Many have argued that there are no true whale fossils found before the late Eocene. And so whale fossils must be post-flood. But my question, Mike, is basically, isn't that based on a KT boundary model to make that point?
Yeah. If the boundary is high up, all those whales are from the flood. And we don't have to worry about them evolving from land animals. I better not get into that subject. Anyway, yeah, that's only because they have a low boundary, and that's one of those hundreds of distinctive mammals that just suddenly are there, like in the Eocene for the whales, that you have to explain how did they suddenly pop up there in the Eocene. It's like that with a lot of other organisms. And then a lot of them go extinct at various times, and they claim very precise times. And globally, these aren't just local things. They get this geological column, they believe, is global. And so if the whales supposedly evolved in the Eocene, that's globally. They originated in the Eocene around the globe. And so forth with extinctions. It has to be global at a precise time. And that, I think, would be very, very difficult, if not impossible, for people who believe in a KPG boundary to explain.
I've seen some creationists that hold to the KT flood boundary. They would say in response to that, well, whales have blubber and most marine mammals don't. So maybe whales and dolphins would have been more likely to float rather than dying and being buried. But if we hold to a higher flood boundary, as you're proposing, we don't really need to appeal to that kind of explanation, because you're saying a lot of the whale fossils that we have are actually from the flood.
Yeah.
Okay, very good. Sam, I'll hand it over to you, brother, and feel free to ask the next question.
Yeah, thanks. Hey, Mike, I have a question about all of the erosion. We talked so much about erosion, and that's an excellent point. But it seems like that erosion at some point is going to need to end in the ocean. So, is there evidence of sedimentary deposit these millions of years, if that was the case, on the ocean floor?
You kind of faded out there towards the end.
I'm wondering if there is evidence on the ocean floor to represent millions of years of erosion.
Well, in their time scale, yeah, because we did a big. They got they have great evidence on the sediments in the ocean now. They're mostly along the continental margin. In fact, some continental margins are 20 kilometers deep below the continental shelf and slope. 20 kilometers. And that, I believe, is the signature of the runoff. That's where they ended up. The runoff as the continents were coming up. Now, there's even controversy on whether the continents came up after the flood. And the deposition of the sedimentary rocks on the continents. We're estimating that at the peak of the flood, and by when I say we, I mean John Reed, Peter Clever, and myself, that have a project that we've called flood sediments. We believe that at the peak of the flood, there was about 3,500 meters average on the continents. And the top 1,900 meters of that got eroded off during the recessional stage and formed the continental shelf and slope. So, did I answer your question, or did I get off on a rabbit trail? I'm not sure.
No, I think you answered my question. I have another question from a global flood perspective versus how this deep time paradigm. Are there any layers that the seculars would suggest can't be formed by a global catastrophism?
Well,
and how would you respond to that?
They believe that all these layers were formed by generally slow processes over millions of years. So I don't think they believe that too many sediments were deposited catastrophically.
But can we show that these layers can form fast by processes instead of time?
Yeah. We have analogs of even forming layers quickly. For instance, a subglacial flood in Iceland, as it came out from underneath the ice, backwashed up a side canyon and formed thin layers, I think over 1,000 of them in, I think, less than a day. And the Lake Missoula flood, when it was spreading through eastern Washington and eroding, it was about, when it got down to southern Washington, near Pasco, Washington, they formed a lake about 600 feet deep because all the water couldn't go through the Columbia Gorge, so it backed up water and formed an instant lake about 600 feet deep. And it sent pulses up the side valleys from that lake that formed a layer of what they call rhythmites, 100 feet deep in a matter of days.
What would you say to somebody who suggests that limestone can't be formed by a flood?
We don't really have a good theory on the formation of limestone. It's an interest of mine. There's so much limestone. The amount of limestone in sedimentary rocks, including, we'll say carbonates, including limestone and dolomite. Dolomite is about half the carbonates and limestone the other half about. But carbonates are about 25% of all sedimentary rocks. So that's a chemical sediment. So where'd that come from? Well, I think it had to come from below the ground, maybe in the fountains of the Great Deep. As they erupted, they had a huge amount of chemicals in it. And there's some evidence that that's the case because we actually have lava flows that are more than 50% carbonate now, called carbonatites. And we have evidence of extinct volcanoes, dozens of them, where they came out with carbonate lava. So there's carbonate down there below the ground. And there's other indications. So I believe that it came from the fountains of the Great Deep. When they erupted, they added all kinds of chemicals to the water, of which calcium carbonate was one of the major ones, especially when you find it starting way down the Precambrian, the carbonates start.
Actually,
So
I was going to allow. So basically, and I think that's a very interesting point, because I know it is another controversial topic, the limestone formation.
yes.
So since it's a chemical sediment, as you're saying, Mike, the chemicals released during the fountains of the Great Deep at the start of the flood could possibly provide the necessary conditions to rapidly form this limestone.
Yeah, I think so. And the dolomite. I've studied the dolomite especially, and it's actually should be called dolostone. Dolomite's the mineral that makes up dolostone, and there's a lot of it, especially in the Precambrian. I did a study that indicated that to form that, you have to have temperatures of the water well over 100 degrees centigrade to form it. That was published in the Journal of Creation and also another article in the Creation Research Society Quarterly. So I just worked on the temperature of it, but as far as the origin of the carbonate, that's what I lean towards. But details need to be worked out on that. Same with the idea of evaporites. They should be precipitates. That needs to be worked out. We have a lot of details to work out. So I freely admit that. But if we get the big picture of the flood down, then we can start working on these details, which I've been doing some of that.
Yeah, and it seems like, even if we don't have the limestone formation figured out 100%, I've worked with limestone. It's a very soft rock. And so it seems like there would be an erosion problem with limestone also. It scratches very easily. It breaks apart. So, if limestone was formed, millions or billions of years ago, it seems like we would have masses of erosional evidence if that were the case.
Oh, yeah. You see limestone formations that are just thick and you don't see erosion in them.
Mm-hmm.
Sure. Yeah.
Now, what I've found, Mike, a lot of your critics, and by critics I mean those that reject a global flood, evolutionists or even atheists, they will ignore for the most part the big picture evidences that you point to show that there was a catastrophic worldwide flood, and they'll hyper focus on these details that we are still researching and figuring out, like limestone. And so if they were to say, well, because you don't have, let's say, the perfect solution to limestone or the heat produced at the flood, that disproves a worldwide flood. What's a good response to that? Where they just completely reject a worldwide flood because of some of these details we still have to work out?
Well, I could say several things. First of all, we have the big picture.
Mm-hmm.
The sedimentary layers laid over huge areas, one on top of another, with billions of fossils, maybe trillions of fossils in them, and then a lot of times planation surfaces at the top. But then these details that they want to glom onto, a lot of times when you look at them, you find out that they can't explain those details either. When I do a research project, I look at the data first as well as I can, and I find out that there's contradictions to their scheme, like evaporites. They claim are evaporites. Some are so thick and pure over huge areas that it just blows your mind that could form by uniformitarian processes. And I find that all the time. Ice ages, that's my favorite topic I've worked on for 50 years now. Anyway, they will claim sometimes ice ages are easy. Get a little cooling pressure, you got your ice age. But experts, when you dig into the data, say it's a very difficult problem to form an ice age. And they'll give you reasons why. And I got lots of evidence and quotes and stuff on that. So they're challenged just like us a lot of times on these details.
Right.
So that kind of makes us even in a way. So they should use that as a rejection of the flood. They should look at the bigger picture to see if the flood is a real. That's why I started off this in the previous presentation, the flood post-flood boundary, with the big picture evidence for those skeptics that will watch this. And I hope they do.
Oh, they do. We have a lot of critics that watch this channel.
Okay.
Some of our biggest fans are critics, but that's good. You know, we're giving them the truth, and they're staying objective and open-minded. And so what if a lot of these evolutionists were to say to those lines of evidence, okay, those features, those geological features are representative of catastrophic events in the past, but they would rather point to multiple local catastrophes rather than one major worldwide catastrophe over a year? What would be a good response to that?
Well, I think I'd have to analyze what particular local catastrophe they're talking about. Then I have to think about it. One thing they explain is polystrate fossils, like vertical trees through several layers,
right?
Even through some coal layers, I might add. They will say, and I read this, that it's local rapid sedimentation just in that one spot. But a lot of times you should be able to trace the strata further out and say, it's more than local. It's probably more regional. But they usually don't do that. So that's one example that I've come across where they will claim a local catastrophe, rapid deposition to cover up that vertical tree. But there's a lot of vertical trees in the sedimentary rocks, I might add. And so you'd have to have a lot of little catastrophes to account for them. I think I published a decent amount on that topic, but I run across so-called vertical trees in a lot of different spots. Most recent was in Theodore Roosevelt National Park in southwest North Dakota, where they had hundreds of these vertical petrified stumps that were flared out at the base, and they went up about maybe 4 feet, and then they were chopped off. I mean, it was uniform for all these, and the bottom has no roots or no soil. Peter Kleberg and I documented that in the Creation Research Society Quarterly, maybe about 2 years ago, on the subject of the Williston Basin. So you look at the details of all these features, and you find out that a lot of times what they say doesn't make sense, because especially with some of these vertical trees where they have to say local rapid deposition, where they have no roots, no soils, a lot of times no branches, no bark. It's you'd explain it by the log mat model of floating logs and vegetation, where you have some vertical logs sinking here and there as the bottom is forming sediments. So we have explanations for those things by the log mat model.
Right.
So I've run into these things here and there, but it depends on what specific area they're talking about, that where I'd have to look at the data first.
There is one specific local flood appeal that we'll get from the Christians that will reject a normal, honest reading of the Bible, and they'll suggest that the global flood was actually a local flood.
Oh, yeah.
And so 2 questions. The first one's kind of rhetorical. You know, they'll say that the local flood still had to cover the mountains, but those are some of the highest mountains in the world. So how does that work? And the second question is there any large local layer in that area that they can appeal to support that there was a local flood in that region? How would we respond and refute that?
Well, to me, the biblical evidence is pretty clear it's not a local flood, but your first objection they bring up is how can it has to be a local flood because the flood can't cover all the high mountains on the earth. Is that the first?
Well, yes. I mean, they would say that, but they would say that it did cover some of the mountains in that area, but those mountains happen to be some of the highest mountains in the world. So I don't think that works.
Okay. As far as covering the mountains, there are many mountains that are sedimentary rocks with marine fossils. And if you read Psalm 104, verses 6-9, where to drain the floodwaters, God says the mountains rose, the valleys sank down. You can show that that these mountains came up out of the floodwaters at the recessional stage of the flood. You don't have to cover Mount Everest in the Himalayas. Mount Everest has marine fossils in the very top. No, that whole area that came up out of the floodwaters and rose above the floodwaters, and as the floodwaters were draining. So that's an easy objection, but it's interesting where a lot of theologians glom onto that. But I think a lot of them are intimidated by the secular geologists who bring up objections like this. But a lot of times, some of them have easy answers, like the covering of Mount Everest, for instance, and other high mountains on the earth. So that's what I'd say for that first objection. But what was the second one they bring up?
The second one is there a local layer that they can appeal to support their claim that it was a local flood and not a global flood?
Usually not, because as all this land was coming up, it was well eroded. So we had erosion. So you can't find a layer that was deposited from this, usually these local floods. Now, one large local flood or regional flood would be the Lake Missoula flood, which I've investigated. Since I'm from Washington State originally, and have traveled extensively out there in Eastern Washington. And that was a regional flood caused by an ice dam that burst. 2,000 foot deep lake burst, carved up Eastern Washington. 50 cubic miles of basalt and silt were eroded. And yet the only places it deposited would be in big gravel bars and in some of these, when you had that big lake form in southern Washington, it washed up the Yakima and the Walla Walla River Valley, forming layers totaling 100 feet deep of rhythmites. Very interesting stuff. But that'd be deposits from a local flood, and I'd go along with that. Yes, sure.
Mike, we have a critic in the chat, and their explanation for polystrata fossils, the trees specifically, is, and I've got it up on screen, he says they are caused by local flooding in marshes and wetlands. So basically just many local floods.
Okay.
What are your thoughts on that?
Yes, that's what they say. Because, a lot of these polystrate trees are in coal seam areas. Yeah, that's what they say. That's what I read, where it says it's local rapid deposition, because it's obvious that you got to bury the whole tree or it's going to be rotten with time at the top or in the middle. You got to cover it rapidly. Yes, that's what they do say. So
now,
what's the question then?
So basically, do you believe from your research that is a plausible explanation? Because that seems, wouldn't that be many huge local floods rather than just admitting for evidence of a worldwide flood?
It's a plausible uniformitarian explanation, but it's, in a way, it's kind of like special pleading. It focus it on one spot, because a lot of these layers, you can stretch them out. You can find these layers going way out there.
Right.
So if you got a rapid deposition in one area where you have the vertical trees, and the layers are generally the same for maybe 20 miles out. Well, you got more of a little local flood. You got maybe a semi-regional rapid deposition. And then when you add up all these vertical trees we find in a lot of different spots, you'd have to have a lot of these local semi-regional floods to account for it. So why not just add it all up and say, hey, it's just part of one huge global flood?
Right.
That's what I do.
Well, because 2 Peter 3, right? So people in the last days, they'll deny the worldwide flood, the world that then was being overflowed with water that perished.
That's right.
So
That's right.
I've got a curious question based on your presentation. And again, I love your research. You did a presentation with us maybe 4 months ago now, and I think we titled it Incredible Developments on Flood Research. And it was really good. Again, comprehensive as usual, Mike. And so my question is, what are your thoughts on creationists or skeptics to your specific pre-flood flood boundary that would look to stromatolites as a counter, basically?
Oh, yeah. Okay. Good question. Stromatolites. First of all, I've seen a lot of stromatolites in Glacier Park. A lot of them are dolomite. And if it's primary dolomite, you got stromatolites that were formed over 100 degrees centigrade. And since dolomite, primary precipitation of dolomite, you need water over 100 degrees centigrade. But there's a lot of limestone stromatolites. But when you compare stromatolites in the rocks to what we have today, which the best examples are Shark Bay in Western Australia, there's some differences. A lot of times those in Shark Bay are isolated mushroom-shaped features. Well, the stromatolites you find in the rocks are just wavy patterns that go long distances horizontally. They don't seem to have a lot of separation. They're bulbous in spots. In fact, in one place in Glacier Park, which is part of the belt supergroup rocks, I might add, we saw an outcrop where a beautiful stromatolite section, which is all these domes, it was great, and it just transformed horizontally into layered limestone. Horizontal layering. So we're thinking that Peter Kleber was the one who came up with the idea that these are convolute deposition or something. I forgot the term, but it didn't seem like it seemed to be a problem for a stromatolite interpretation for these wavy things, and they're continuous with little separation. Also, the stromatolites, like Shark Bay, the microbes bind particles, and a lot of times these particles are not necessarily limestone. Well, practically all stromatolites in the rocks are in limestone, which means that maybe we have a need a non-biological mechanism unique to limestones in the flood to account for them. And also, you'd expect you'd find a lot of microfossils. And you don't find too many. They're rare. And when you do, they don't seem to be necessarily connected to form the nice mushroom-shaped domal features of the layering. The ones I've seen have been kind of random type microfossils. And they're rare. They're actually rare. You should find a lot more microfossils if these are really biological. So I'm leaning that practically all stromatolites in the rocks are non-biological. And I'm doing research on that with Peter Kleberg. And we'll emphasize Glacier National Park, where you have a lot of good examples. And we're going to go from there. So we've read a lot of papers, and so we're going to and we'd like to find non-biological mechanism from chemistry, but because it's non-uniformitarian, probably unique to the flood, unique conditions, it's going to be a challenge for us to come up with something. But that's our ultimate goal, to actually come up with a mechanism from the flood. But meanwhile, we can do a lot of other things, show that they're quite different than modern stromatolites, which make you think that, hey, maybe they're not biological. Anyway, that's our position on this. We just started this research, but I've been thinking about it for 30 or 40 years, these stromatolites, and I've seen a lot out there. And I even got one nice one in my basement somewhere. I mean, in my garage somewhere.
Well, you do a lot of great field work too, in terms of your study, and there's a lot of internal discussion on these issues within the young Earth creation community, and that's why peer review and also just kind of in-house discussion is so important on these subjects. And correct me if I'm wrong, this kind of goes back to the Green River Formation question. And then Sam, I know you had a question on the fossil record, but you did years ago an in-house written debate on that topic.
Yes.
Right?
Yes, I did. In 2006 in the Journal of Creation. So, yeah, that was with John Whitmore.
Right.
And he was the guy I went out in the field with, and he showed me things I couldn't explain that seemed to indicate it's post-flood. And I showed him some things that would be difficult in a post-flood environment. But I think the big picture of the Green River Formation says flood. But I'd like to be able to explain all those nice, challenging things that he brought up, but I just don't have enough information at this point to do it. Like, one of the most challenging is caddisfly burrows that he showed me. Hundreds of them in limestone. I even have them, some in my garage. So I would tentatively explain this by the beds model, that you had a lot of, and by the way, we have bird and mammal tracks in the Green River Formation. that in places it was exposed as a big bedding plane for a while during a local drop in the level of the flood, and organisms made tracks, and then insects made their caddisfly burrows on the beds that was exposed maybe for a week, and so that'd be my tentative explanation, but that's at this point would need to be worked up. I'm just giving you off the top of my head explanation of how I would approach it.
Well, that's good. That would have been my follow-up question, was how would you approach that? So Mike, I appreciate that. Sam, over to you, brother.
Yeah. So Mike, sometimes the critics of a biblical flood, they'll suggest that we cannot explain the sorting of the fossil record hydrologically. And so I'm wondering how you can respond to that.
Well, most of us believe that the fossil record is a record of burial of ecosystems. Like most of the Paleozoic are marine fossils, so we're talking about a lot of creatures that lived in the ocean, buried first, and then above those, a lot of times you have the ordering of the geological column in general in a lot of places, especially in the western United States. And so you have the dinosaurs on top of the marine fossils. And then near the top of the Mesozoic, you have the flowering plants and the diatoms that show up. So I'm thinking that these are buried ecosystem with dinosaurs and flowering plants that they were eroded kind of later, and they were spread over the marine fossils that contain the brachiopods and a lot of the marine creatures of the Paleozoic. And then the mammals came later, maybe from higher areas. But so I think it's it could be explained in general by a vertical zonation of ecosystems and horizontal. I don't think as creationists have emphasized the horizontal aspect, that in some areas, say 2,000 miles away, you had more lycopod forests, and they got torn up and deposited in the eastern United States. But you had more angiosperm and tertiary and Mesozoic trees come from a different area, maybe 1,000 miles to the west. So I think there's a horizontal zonation. But I'll admit to the critic that we need to have more details on all this. And at this point, I'd say we're just in the beginning stages of a decent flood model. There's hundreds of challenges. These are just a couple that, but we have the big picture. That's the point I make of that. We're filling in the details, but we have to remember, number one, we don't know all that much. There's a lot of unknowns in earth science, lots of them. Secondly, I don't think we're all smart enough to put it all together.
That's true.
So that's why we have at least 100 earth science journals out there. I try to keep up with about 50 of them. And they're always doing research, finding new things. So that shows you how many unknowns there are. And so those things are cause us to, and also we don't have enough researchers. That causes us to not, at this point, have filled in a lot of the details yet.
Well, we're not necessarily getting these massive grants,
Right.
To
That's
in order to carry out these research programs on burial by ecosystems. And I guess,
yeah,
in order for me to better understand the burial by ecosystems model, so you're essentially saying, Mike, that you'd have entire ecosystems of animals and their associated plants, catastrophically buried, but taken from one geographical location to another.
Yes.
So, and would that mean that where we find them is not where they originally lived, or where that
hardly
ecosystem?
ever, I'd say. I mean, the strata are deposits that were transported from some other area.
Right.
And I mean, we don't know where all the strata originated.
Right.
Because if you had 3,500 meters average on the continents at the peak of the flood, where did that strata come from? Did it come from the continents themselves? I'm not thinking so. But I still have to hash this out, even among our group of three doing the flood sediment research project. And then it has to be transported. They have to be catastrophically eroded fast, transported fast, deposited on the continents, 3,500 meters thick, only on the continents. That's the interesting thing. And then during the recessional stage, you take off 1,900 meters and form the continental shelf and slope. That part is easy to understand, but getting those 3,500 meters average at the peak of the flood, I think this is my topic 4 months ago that you're talking about. That's challenging. And so we're still doing research and gathering the data. So we don't have enough to really have too many answers on that. Sorry. It's just, it's a research project in process. Two maps I showed you there in color, the mid-continental rift and the impact basins, are two results of this project so far. We're figuring out what the strata we have remaining on the continents, what it's saying, where the Precambrian basement on crystalline rocks is, that'd be the lower boundary, and how thick all this strata remaining are. And I think we're done with most states. That's why we can make a big map of a lot of states and show the mid-continental rift, showing that it's a crack 50 miles wide, 30 kilometers deep, filled up with basalt and sediments to the point where you don't even know it's there, except Lake Superior is the only spot where it's not totally filled in. That's why we have Lake Superior there. That's recent research. And that is the secular scientists haven't even done that.
So in relation to this, and interesting points, Mike, a comment or criticism came in from a PhD evolutionist, and he basically pointed to the ordering of the fossil record like we're talking about, but specifically pointed to the distinct ordering of fossil plants that he argues supports universal common ancestry. But this burial by ecosystems both vertically and horizontally, would that explain his argument here?
Yes,
basically?
I think so, because I think you had an area where you had lycopods, which are mainly a Paleozoic plant, and that got deposited mostly in the eastern United States. But you don't have a lot of them in the western United States, so you have different types of plants, and they came from a different horizontal area. I think that's mainly horizontal differences there. But where they came from, in general, the paleocurrent directions for the Paleozoic are from the east, off from the Atlantic Ocean. And they're still from the east, if I recall right, whether you have a continent off there or not, or if it's just ocean. So there's still a easterly paleocurrent directions. But in the Mesozoic, in the western United States, it's generally from the west. So you have different current directions depositing the different types of plant fossils laterally. So I think that's lateral zonation.
Yeah, Mike, if we were to accept their interpretation that they have evidence of plant evolution throughout the geological column, it seems like they would also need evidence of bioturbation within these layers. Do we find any of that?
Generally, we find a low amount of bioturbation in the sedimentary layers, while the bioturbation is ubiquitous on the current ocean floor. So that's one thing. Looking in the details of these challenges, you find out that they're challenged. Also, they'd be challenged on the origin of the flowering plants. Darwin said was an abominable mystery. They still haven't figured it out. They're suddenly there in the fossil record about the Cretaceous, and they go up into the Cenozoic. So, yeah, they have problems explaining this stuff too. That's what I was saying earlier. They're challenged too. It's just that in their paradigm, a lot of times, I don't think they talk too much about their challenges. Usually I find out about them when they think they have a solution.
Yeah.
They have the introduction. Oh, by the way, you probably didn't know this, but here's a challenge we've had all along, and here's our solution. And usually I find out it's a speculative idea, but that's how I find out a lot of times their challenges, that they're challenged too. And they try to explain it with other hypotheses, which is the scientific method, which is all right. But a lot of times I find that it's still a challenge, like the origin of flowering plants. It's been a challenge since the time of Darwin and still is. You can get a lot of literature on this.
It seems to me the entire geological column is a contradiction if you step back on their model. Because on one hand, they have to appeal to uniformity over time. If they abandon that, then all of their dating calibrations and all of these things disappear. Their timeline disappears. But on the other hand, each one of these layers represents some sort of significant and large change in the environment. So when we step back and look at all of these layers, all of those layers individually represent something big. But then on the other hand, they're trying to say that all of these things were laid down by uniformitarian processes. And it doesn't seem like both of those can be simultaneously true.
Yeah, uniformitarian processes of deposition are small and local. I mean, hurricanes are probably the biggest phenomenon today that will spread sediments from one area to another. But, floodplains like that, this is generally local, and it changes type of rock vertically and laterally quickly from different types. But that's not what you see in the layers. A lot of times these layers are very extensive and go for like the Tepe sandstone, half of North America. So I'd say uniformitarianism would be hard pressed to explain a lot of that strata, and especially the there's no erosion between layers. That's called the flat gaps.
Right.
Um,
Yeah, it seems like we would expect that if they were going to appeal to some sort of catastrophe like a hurricane that would be picking up these living things and burying them. It seems like we would find the evidence of that throughout a lot of these geological layers. I've been to northern Arizona. It's beautiful, but you see a lot of these layers and a lot of empty space from erosion, and it just doesn't really seem like what they're saying. It doesn't seem like we observe that when we actually go out, at least what I've seen, which is very
I think a lot of the sedimentary rocks and the fossils do not show uniformitarianism. That's why I start with the big picture. They show more of a flood deposition than uniformitarian processes. So catastrophism, they show catastrophism.
Because we see the abrupt appearance of a lot of these fossils, as you're pointing out, the flowering plants, we have the Cambrian explosion, obviously. We have the Permian explosion. We have just an explosion of mammals on scene. And so when we look to something, because an old Earth intelligent design advocate may look to the Cambrian explosion in a different way than we would as young Earth creationists and global flood proponents. And so according to the burial by ecosystem, both vertically and horizontally, hypothesis, Mike, that you're putting forth, when we look to something like the Cambrian explosion, is this an example of a community that was transported from one location to another? And so this is where we find it currently because of the global flood?
Yes.
And then rather than a deep time old Earth creationist, let's say, like an intelligent design advocate, they might say, well, this is evidence of a special creation event. We wouldn't say that. We would just say, okay, this is evidence of a pre-flood community that was transported from one place to another during the flood.
That's what we'd say.
Interesting.
Because it's in the flood sediments.
Right.
So.
Well, okay, so here's a follow-up question. This ordering of the fossil records is a very interesting topic.
Yeah,
and because it really is one of, and we've hosted a lot of discussions on this channel with critics, and they really do bring it up every time. And so this question here comes in from Base Theory. Appreciate it. And so he says, Mike Oard, how can a flood possibly explain the ordering of the fossil record? He's got a detail here. He's saying especially for plankton. So I'm not sure if you've done much study on plankton, Mike, but he is saying that plankton are ordered into layers, but all have the same density, habitat, intelligence, and mobility.
I have not done much for plankton found in the rocks. So I really can't address that. There is one major difference, though. You don't find diatoms until about the Cretaceous. So that's a major challenge for both of us. I mean, diatoms are everywhere. They're in fresh water. They're in the ocean. They're ubiquitous. And so why did they suddenly appear about the late Jurassic to the Cretaceous in the sedimentary rock? I think it's because they were eroded from an environment that only had the diatoms. That would be how I explain that order of the fossil record. Otherwise, that's about all I could say about that. It's something we need to work on. I agree.
So from I haven't done a lot of study on plankton either, but from my understanding, and the commenter can correct me if I'm wrong, plankton can either be a plant or animal
Yes,
species.
phytoplankton and zooplankton.
Right. And so they're carried by tides and currents. And so
Yeah.
basically wherever we find them in the fossil record, if they're pre-flood, are they basically taken from, again, one location to another during the flood? And so where we find them currently, if they've drifted during the flood, I'm just kind of brainstorming here.
Yes. Yeah, everything's been transported. There's hardly any what I'd call fossils or in situ that forming. There probably some. There's some places where you have thick diatomite layers called diatom layers, like the Monterey Formation in California. And you have some polystrate fossils there, like whale skeletons, not vertically, but horizontally with the beds, but still to cover them with diatoms, it has to be some kind of rapid deposition of diatoms to cover the whale skeleton. And the same in the Pisbo Formation in Peru, where you find a lot of well-preserved whale fossils in diatomite, indicating that the diatoms were deposited rapidly somehow from some blooms. Yeah, we probably had a lot of plankton blooms during the flood.
Mm-hmm.
And those blooms can probably explain some of these sediments that are microorganisms like chalk. I think Andrew Snelling has a decent model out on forming chalk in Europe is coccolithopores, and that's a calcium carbonate skeleton, and they probably were deposited over a very large area, and then bottom currents moved them by mass flow and piled them up in a basin. It almost looks like that's the model that we should apply for plankton. The coccolithopore is a type of plankton in Europe, and the diatomite and I've seen it in several areas in the U.S. That would be a diatom bloom that was probably collected by mass flow into thicker layers, rapidly covering up a bunch of organisms. And we have chalk in Kansas and western Kansas and Nebraska. And in there you find a lot of dinosaurs and mosasaurs and marine reptiles. Again, indicating that this wasn't a slow rain of microorganisms, but something had to bury these big organisms rapidly because they're polystrate fossils. So there's a lot of things we can do. These are just some ideas off the top of my head when he mentions plankton. But we have a lot of questions we need answers in that area.
I think those are some excellent ideas. I appreciate that, Mike. We've got a couple questions coming in now from members of our own team, people associated with our own team. So George Bond, who you're familiar with, of course.
Oh, yeah,
George,
okay.
George, good to see you, brother. So he's in the chat, and he's got a question here on screen. And so he asks, since the 90-degree bends at the tapetes is not the product of geothermal processes, no crystallization, he says, how will the secular camp explain it? A moist layer better fits the evidence.
Yeah. Andrew Snelling just wrote a long paper on that in the Answers Research Journal. Just I think about a week ago it was published on this very thing about the bending of the Tapete sandstone, where I haven't read it. So he might be referring to that. So from what I see, in general, they have difficulty explaining these folds in the tapetes and other strata above them implying that they were soft for maybe millions and millions of years, and nothing hard, and it kind of bent all at once, and they have to be, I imagine, wet. But I have not read that, and I've not paid a lot of attention to that issue. But Andrew Snelling has done a superb job on the Answers Research Journal on that. In fact, he has articles over 100 pages on the Tapete sandstone, then the layer of shale above that, the Bright Angel shale, which I might add, you see the equivalents up here in Montana and Wyoming of the Bright Angel shale. And then you have that limestone above called the Muav limestone. And then he just capped it off with this information in the fold. So I think it's probably really challenging, but I've skimmed through the three main papers on the strata, but I haven't gone through the one on the fold yet. I don't know if I answered George's question, or comment, but
nope, that's good. That's good. We've got another fellow young Earth creationist here now as well, who joins us frequently on the show. So T-Rock, and he's got a question for Mike, for you, Mike, and he's asking, do you think there was a seafloor collapse? And if so, when in relation to the beginning of the flood?
Okay. I'm going to have to say I don't know. We don't know what the geography and topography before the flood is. That's one big hindrance from answering that question. I'd lean towards the idea that, in general, the present ocean basins were the pre-flood continents, and the continents were the pre-flood oceans. Yeah. So, but that seafloor collapsing necessarily, probably, but what I'm doing is speculative, but I have reasons for it. And even with the group of three of us doing the flood sediments, we're unsure about all this. But this is not my idea either. This is an idea that was developed by the late Roy Holt. Because you find all the sedimentary rocks on the continents, and you'd expect them to be low in the flood to collect the sedimentary rocks. But John Baumgartner has a theory out that the continents that the ocean basins and continents were the same elevation during the flood general as now. And to get the sediments piled up on the continents, he relies on huge tsunamis in his plate tectonics model to move the sediment up by tsunamis up on the continents. I don't know. I have problems with that, but it's a good idea. It's something worth pursuing, and that's what he's doing. But we haven't figured it out yet.
How similar is your specific model to somebody like Dr. Baumgartner's CPT model?
My model of the flood, which I only believe 60%, is meteorite impacts caused by differential vertical tectonics to drain the floodwaters. So I believe there are probably more impacts than they've been saying. They find new ones every year. Mm-hmm. They have about 200 on the continents right now. Some of them are huge, like the Vredefort and the Sudbury that I mentioned in the talk. But these basins, Williston Basin, Belt Basin, Michigan Basin, Illinois Basin, other basins, I think those are huge impact craters that filled up early in the flood. And so that's I believe started the catastrophism is impact. Not a lot. I think maybe around 1,000 total, if they can figure out. They have very stringent criterion on impacts. Anyway, that's a subject of research. In fact, It's a topic of an ICC paper I submitted
Awesome.
that is being reviewed, but I haven't got any feedback on it yet. But I better get it soon because we have to get these things finished. But anyway, it's about mainly about impacts early in the flood. So that's what I lean towards. I also think CPT is good in a lot of aspects. I go along with it 30%. And some people object to using probabilities like this. But being a weather forecaster for 30 years, you can't say yes or no on some things.
Right.
It may rain or it may not. There's a lot of variables that say yes, and there's some that say no. And that's the way I look at flood models, probabilities.
Mm-hmm.
I give mine 60%. It has problems. That's why 60%. I believe CPT has a lot of problems, so I give it 30%. But it has good things. And Walt Brown's model, I give that 1% or less. Sorry about that.
So you got CPT a little bit ahead of the HPT model then.
Yeah, so I've looked at that, and I haven't looked at the latest information. He's always changing it. So one of these days I'll have to do that. But I'm so filled up with talks coming up and research, and
and you've got a talk coming up at the ICC, correct?
Well, the paper's being reviewed. It's a big paper. It's almost 20,000 words up to their maximum, but I think it's pretty solid. But I haven't heard a thing. I sent it on Thanksgiving Day. So anyway, I expect to be hearing something about it and then starting to work on it if it is accepted. So anyway, I hope to talk about that in the ICC. It's a hope.
I think that'll be great. I think we need gene duplication to occur where we can have 5 Mike Oards and then 1 Mike Oard per topic, because you're studying so many of these issues. So do you believe then, like CPT would suggest, that your pre-flood continent was more of a supercontinent, much like Rodinia, that broke up at the flood? And I guess if you could speak to that briefly, Mike.
Well, that's a bag of worms for the CPT people, because Rodinia supposedly came together from other continents. Colombia is one of them. It came together the Neoproterozoic, and then it broke up sometime in the Paleozoic. And then it came together again to form Pangea, and then that broke up. So the CPTers have always had a problem of what continent broke up. Or did we have 2? I mean, CPT is a mechanism to break continents, but not bring pieces back together. So this is a bag of worms in their model, and they've come to different solutions. Some say Rodinia, some say, they used to say Pangea, but no, that didn't start until the Mesozoic. That's half the flood is over with. Half the strata is deposited. Some say modified Pangea. So it's a mess, and that's one of the problems of many that I have seen with the CPT model. And I wish them luck. I hope they solve it. I would like to believe it down the road totally, but at this point, because of I don't think we can say yay or nay on it, even though advocates of it who strongly believe it say you should say yay and it should be 100%. No, you can't logically do that. Just like I can't do it with my meteorite impact hypothesis. So at this point, I'm going to give them probabilities until things work out. I mean, there's a lot of unknowns out there, lots of unknowns. And as far as, we don't know whether there was one continent before the flood. The Bible says that, it doesn't say that. It says that, what does it say? The oceans, they were seas, but they were in one place or something.
In one place.
I forgot the quote. But anyway, it doesn't talk about there being one continent. So that's an educated guess. Could have been. I don't know. I don't have a horse in that controversy. I could take it or leave it.
Right. Well, you're a big advocate of multiple working hypotheses.
Yes, I do.
Are you skeptical over the massive cold slabs that we find deep within Earth's crust? Are you skeptical of those being due to rapid plate subduction?
What slabs?
I guess these cold slabs, I often hear Dr. Tim Clary speak to those a bit.
Oh, yeah. Okay. Yeah. When you, a subduction zone is a cold slab, and I think there's a lot of assumptions on the temperatures there. But supposedly they go down. Some of them hit the transition zone,
right,
between 410 and 660 kilometers vertical depth, and they stop or they move out to horizontally. Some are believed to penetrate all the way down to the bottom of the mantle, and they discover big areas of hot spots. Two big hot spots, maybe 5,000 kilometers in diameter, called large. Well, I can't remember the name of that. Anyway, they're hot spots, and they're, by definition, they're surrounded by cooler spots, which they consider the slab. But there's a lot of glitches in that, because the data actually shows that seismic waves move slower through those areas that they believe are hot. They might be more due to composition. The secular scientists are divided on this, by the way. And the projection of the slab down to the lower mantle doesn't quite line up with these areas where they believe are warm, very lower mantle and cooler. So there's a lot of glitches in that. It's not very straightforward. And that's an area I keep up with. And there's problems with it.
Are they just basing the temperature on density? So they're saying that these slabs of rock are the same density as they are at the surface. And so because it's...
it changes density as you go down. That's another factor. You have transformations of minerals. And so I think the crustal part of the slab actually becomes more dense than the mantle as you get down there. And so, I mean, there's a tremendous amount of ideas in the secular literature on that. And I don't think you can use that as good evidence now. I mean, I think you can use it as speculative evidence at this point, but not good evidence, because a lot of glitches when you read the secular literature. They don't know whether they think they're mostly temperature differences. And some of those claimed temperature differences of all temperatures would be radically different. It's too radical. Because, I mean, if it was 3,000 degrees centigrade warmer, it'd be wanting to come up really fast.
Right. So
a lot of secular scientists think, and they have data to prove this, or to demonstrate it, that it's mostly composition, but then others say it's mostly temperature. Some think it's both. So they're not sure why the seismic waves slow down. And when you get really low near the core mantle boundary, say 25 kilometers, then you get into what's called the ultra low velocity zone. And the waves slow down a lot, but they don't know whether that's part of the core material that's come up and is due to temperature or its composition. So the upshot of this is it's still an area of research, and we should be careful not to say this is proof of CPT.
No, those are some great points. I appreciate that, Mike. I could ask you questions and talk to you all day. So why don't we start winding it down, Mike? We're always very thorough with you, and time flies by.
Yes,
so,
I see that.
yeah. So what we'll do here is wrap it up with one last question. And to the audience, we always have an excellent audience with you with a lot of feedback, input, and questions. This is Mike's 10th time here. So please check the playlist in the description box and you'll find all of his previous shows where we typically have the same format, detailed presentation, and then about an hour and a half of discussion. So if your question wasn't necessarily answered tonight, I have a feeling it was probably answered in one of the previous nine shows. And Mike will, of course, be back again in the future. So I guess we'll wrap it up here with the last question. Jim P, he has been waiting patiently, and he's asking, what mechanisms, Mike, do you believe best explain the cooling of the ocean after Noah's flood?
Yeah, I believe that after the flood, we had so many warming mechanisms. We're going to have a warm ocean from top to bottom and pole to pole. And that's going to fuel the ice age. With the warmer the water, the much more the evaporation. The ocean cools by two mechanisms, evaporation and what's called sensible cooling. That means contact. In other words, cooler air coming off the continents, hitting warm water, the oceans cool and the water and the air warms, you see, and that helps cool the oceans. And evaporation is another one. In fact, evaporation is 3/4. I've done these calculations in my ice age models. Evaporation is about 3/4 of the cooling mechanism. Evaporation is a very powerful cooling mechanism. And while contact is about 1/4. But there's a heating term, and that's by solar radiation. And during the ice age, there's a balance, and you get a change in temperature, change in time. But the net effect is a gradual cooling, and that's how we can time the ice age to be only hundreds of years and not tens of thousands of years. And you can get all this information in my articles and books about all this stuff. But so those are the two only two mechanisms for cooling the ocean would be by evaporation and by contact of cooler air moving over warm water.
Sam, was there anything you wanted to add, brother?
Well, yes and no. I mean, I'm wondering, depending on what flood model you hold to, some flood models, the critics will say pose a heat problem. They'll say that the continents heat up too much that would cause water to boil off and such. And so, it's always interesting to ask if there is a mechanism that someone is aware of that might help with that. It's an alleged problem, and it presupposes that God isn't in control of his creation. So I reject that immediately. But, it's fun to talk about. So what do you think about that?
Oh, yeah. All flood models have a heat problem. And I think that it says in the Bible that God started the flood, he was in charge of the flood, and he ended the flood.
Right.
And I believe he took care of the heat problem. See, we have a huge heat problem with accelerated radiometric decay,
right,
which I believe in. Probably during the flood and the creation time, I don't think it's certain when it happened, but at least some was during the flood. And so that's your biggest heat problem. And so I go along with John Baumgartner's answer here, and that he believes that God took care of the heat problem. I think that's what it did, because we have to cool a lot of lava flows quickly, like the Columbia River basalts in eastern Washington, which I'm familiar with. Those are many lava flows. And so, I mean, if you cool them off by conduction or some kind of convection, it's going to take a long time. And so I think that's part of the heat problem that God took care of. And so that's what I as it is, I do not see any mechanism to get rid of the heat. So that's how I'd explain it, that God was in charge and he took care of it.
Now, and you're saying that the worst source of heat would be the accelerated nuclear decay. And I'm curious, do you see radio halos, the existence of radio halos, as good evidence that accelerated decay happened?
Oh, yeah, I do. but I find that they're difficult to explain to the lay people, so I don't really use them. The one I use is Humphrey's
Helium.
helium diffusion argument. I think that's solid evidence that we had accelerated radiometric decay, helium diffusion argument. So I use that, and lay people can understand that, because I talk about dating methods to lay people, and I use just two of them from the RAPE project. The carbon-14 and coal and diamonds from John Baumgartner, and Humphrey's helium diffusion. Those to me are very solid, and the critics have tried to shoot holes in them ever since the beginning, but I just think they're grasping at straws, and so they're very solid evidence.
Have you researched at all Dr. Russell Humphrey's paper over the last few years, at least, where he talks about the heat problem and the possibility of God stretching out the heavens? I think either during or after the flood might take up a lot of that heat. Have you looked into that at all?
Yeah, not in depth, but I know about the idea, but it doesn't seem plausible to me that that would work, because it's stretching out the heavens. That's one thing, but I mean the heat problem is down in the rocks and the water.
Right.
So how are you gonna stretch some of that? So I think it's a long shot at best.
Mike, let me ask you: is it possible that some of this evidence of that radiometric or that decay is left over from creation and wasn't all created at the flood?
Yes. You might find a lot of it, and I think the rate scientists have been they have not pinpointed it, but they'll say the creation flood or both, and I don't have anything to add to that, and I think both are plausible, and but we know what happened from Humphrey's research, and also the halos are good evidence. But like I said, they're difficult to explain. And I tried to do it in a Sunday school class this winter.
It's not easy, especially with the radio halos, Mike. It's tough.
Yeah, it was tough, and I think I lost half my audience.
If you don't mind, I'm just trying to squeeze in one little question.
Sure.
We've discovered a lot of that mineral called ringwoodite. And I believe that makes up a majority of this surface layer. And I'm wondering if any of the tests have been done on this particular mineral, because from what I understand, as it heats up, it lets the water out. So if a lot of these physics tests haven't been done on this particular mineral, I'm wondering if that changes anything.
Ringwoodite and another one, wadallite or something like that, are transition zone minerals. They are found 410 to 660 kilometers down deep, and they're formed by phase changes for the peridotite of the upper mantle. But you don't find that at the surface that I know of. So they have a lot of water in them, but how are you going to tap that water? Because it's so deep down there. So yeah, I don't see that as a good source of water, even though there's a lot of it in those two minerals down in the transition zone.
My thought was, and I'm probably way off, but as the earth maybe heated up, that water would escape and lifted the continents and caused things to move, and that would have been the fountains of the great deep bursting forth. Now, I don't have any evidence or anything to support. It was just a thought when I learned about that very recently. So I just thought I'd throw it out there. Let your rest.
I have no comment, because
multiple working hypotheses, right?
Yeah.
Yes.
I'm not even there. It's just a thought. So
yeah, I understand that. I have a lot of thoughts like that.
So if what you were saying earlier, gentlemen, that a lot of this decay then happened during the creation week, since the creation week was a sped up week, rapid processes taking place, wouldn't there then be supercooling going on at the same time, which basically would mitigate the heat, at least during the creation week itself?
Well, sure. Creation week's a super miracle by definition. So,
right.
Yeah, he took care of all that, and forming all the earth in a short time. Yeah, I would kind of lean that most of it was down there, but in creation week. So I can go along with that. But
well, obviously the accelerated nuclear decay is going to create most of the heat, but at least some of the heat may be created through friction from plate movement.
Yeah.
Could some of that be utilized to rapidly form the coal plants, natural gas that we see on the earth today from the flood, since that requires heat and energy?
Yeah, you do require heat. Yeah, you could have had enough heat buried down there to form the coal and the oil, because you need heat for that. And that maybe is just was engineered by God to do that at a certain rate, and so that we have coal and oil and natural gas, and not worry about global warming. Let's not get into that.
Right? Yeah, it's a controversial one on YouTube, that's for sure. They'll stick that warning right on your video these days.
Yeah.
So Mike and Sam, thank you so much for being co-host. To the audience, I mean, we're almost on 3 hours and we've still questions, feedback, input the entire time. So Mike, I look forward to rewatching your presentation, as I usually do, many, many times, just to absorb all the information that you're providing us. And I always look forward to the Q&A afterwards, because like you and like Sam, these ideas are always floating around my head, and research is fun. It's a great time to be a biblical creationist. There's lots for us to research, study, and keep us busy. So who needs sleep, right? Mike, I want to hand it to you, brother, in case you had any final words and final thoughts before we shut it down for the night. And again, excellent job today.
Well, my final thought is that we have the big picture. The rocks and fossils are from the flood. And we've actually got good answers to some of the details, too. That's in 60 years of creation research, technical literature, and even in popular creation magazines. We've showcased it. But there's a lot left to do. We don't have enough researchers. There's so many details, and a lot of the details we don't have enough information. Just don't have enough information to put it together. So I'd ask for patience for those that really want answers, like me. We got to have patience. Research is slow, so be patient with us.
Amen. Great final words, Mike. Always a pleasure, always a privilege. I love these detailed technical presentations and discussions. These topics fascinate me. So, Sam, my award-winning co-host, thanks for being here, brother. Appreciate it. Always great to have help. Any final thoughts, final words from you?
No, hey, I want to thank you, Mike, and you too, Donny, for having me on. I really appreciate it. I love having these talks with you guys. And to the Christians out there, don't let that dust accumulate on your Bible. And to you critics out there, we love you guys too. And so, we're calling again for you guys to be reconciled to the God you know.
Amen.
Amen. Well said. Perfect place to end it. So, gentlemen, thanks for being here. To the audience, thanks for tuning in. Appreciate the questions and feedback. And God bless all. Standing for Truth is out.